This is going to be the first in a series of 2 lectures on the stomach. The first place we're going to start is with the 4 regions. And it would be good if you have your coloring sheet handy and nearby, so we can reference that as well during this lecture. So 4 regions of the stomach are identified here on this little drawing. They do a good job in this anatomy coloring book. They give you some of the tissue layers here, the regions of the stomach. They even come down here and look at the mucosa and the histology of it, which is what we're going to focus on in our lecture tomorrow. But today the regions of the stomach are, number 1 is the cardia. I don't know directly what, because cardia means what? Heart. I'm not sure directly what this region has to do with the heart, except it's the closest part to the heart. It's where the esophagus attaches. In addition to that part, and see on this picture I can show you, it's right here. Just this little tiny area is the cardia. And it's really close to where you're going to find that sphincter here too he was talking about in the video. That a sphincter, did I talk about sphincters at all?
Sounds familiar, but
okay.
I remember.
All right. Maybe I'll put this in a little box up here. A sphincter is a round muscle that blocks passage. Okay? When I say sphincter, most people think of the anal sphincters, which is why in the video he probably described them as being the most popular ones and ones that people think of. And that's the case here. They block and or allow passage as they open up. Basically, it's a round muscle, something like this, and so it can open or close to allow things to go through or not go through. Such is true with the anal sphincters, allowing us to poop. Such is true in the stomach as well, holding on to contents to make sure that they can be digested before they're passed on. So cardia has the one at the top of the stomach, the sphincter, that's really important at making sure that material, that acids don't churn back up into the esophagus. What do we call that? That's, yeah, esophageal reflux or acid reflux. The next area is the fundus part of the stomach, and it's called the fundus. See what I did there? And that is the most superior part. And for like gastric bypass surgery, the fundus is actually pretty important because that's where that's pretty much the majority of what the stomach is made of, is just the fundus. And it's just this region that ascends above here, okay? That is the fundus. The only other place I've seen fundus in anatomy was on the uterus. The uterus has sort of that shape as well, where at the top it kind of curves up and then the fallopian tubes come off the side. The top portion of the uterus is also called the fundus, so I think it just has to do with how it looks and what connects to it. The next portion is called the body, and that's the largest portion of it. The body and the majority of chemical digestion, and breakdown and mechanical breakdown happens in the body, and it's huge. It's like all of this section from here to here is the body. And that last little bit right there, that last little section is called the pylorus. It's that last curve, last J-shaped curve. That's where stuff goes before it's sent on to the small intestine. And this is right at the end of the pylorus is another sphincter right there. It's called the pyloric sphincter, and that's what keeps material in the stomach so it can be digested before it's sent on. Now let's talk about some of these layers here, okay? So on this side, let's do layers of the stomach. Which in reality works out to be the majority of layers of the digestive system. Same as most of digestive system. Because you'll find a lot of these same muscular layers in the small intestine and the large intestine and so on and so forth. So from the outside to the inside. Okay. Outside working our way in. So when we went to the cadaver lab last Monday or last semester, if you touch the intestines or the stomach or any part of the digestive tract, the layer that your fingers or your glove, should have been glove, made contact with was the serosa. That is the outermost layer of all the digestive tract. So if you're looking inside of a cadaver and you can see the digestive organs, the layer you're looking at is the serosa, the outermost layer. If we get inside of, let's take a look at that real quick here. This is the serosa, the outermost portion of the stomach right there. If we get inside of that, we're at a tissue layer of muscle. The next layer is called longitudinal muscle. That's not us. Okay. You can't. Yeah, what? You can't bail on me like that.
That's advisory.
I wonder why they didn't change the bells today.
Probably forgot it one day.
That's probably why. That's a good logical conclusion. Okay. Here, folks, this is a longitudinal muscle. It runs the length of the stomach. So it squeezes the stomach from top to bottom to shorten it that way. But we need to be able to squeeze the stomach in every direction. So that's what the next layer is. Underneath that layer is a layer that circles the stomach, conveniently called circular muscle. And it goes exactly perpendicular to the longitudinal muscle. We have this is what's labeled H right here, and it wraps around this way to squeeze the stomach in that direction. So we have it going this way and this way. And just to make sure we have all of our bases covered, the next layer of muscle kind of splits the difference. It goes downward at an angle, very much like the muscles on the side of your abdomen go downward at an angle. What were those called? The ones on the side of your abdomen. External obliques. Okay, and that's what this is because of its shape. O-B-L-I-Q-U-E, oblique muscle. So between these three layers of muscle, your stomach has a tremendous capacity to contract and pull in on itself from every direction. From there, those are the three layers of muscle. From there, we go to submucosa. And finally, that should suggest that we're going to end with what? Mucosa. This is called submucosa because from the inside out, this is underneath the mucosa. And then a mucosa is making what? Mucus. This is the layer that touches the food or digested material. All the rest of this stuff should have no contact with the food, but here this will. The innermost layers will. Lots and lots of layers. And in the stomach, lots and lots of mucus. So much mucus produced, in fact, that it makes a gel layer on the inside of the stomach to protect the stomach from digesting itself. As a result of this gel layer, we are not able to do some things the other part of the digestive tracts can do. There is very little nutrient absorption. This is a weird word. Absorb ends with a what? B. But absorption has a P in it. I don't know why, but it does. I had to look it up earlier. Very little nutrient absorption happens in the stomach. because it is lined with a protective mucus gel layer. That's what protects us from peptic ulcers. So our acids with a pH of 1, sometimes pitching toward 0 in our stomach. The pH is so incredibly low that if we didn't have something to protect the inside of our stomach, we would literally be digesting ourselves. What's rough about peptic ulcers in the stomach is that they bleed, and you bleed into that spot, and you can't. It's hard to heal from that. So you're continuously digesting a trickle of your own blood. It's a pretty rough deal. Okay. Now, the type of digestion that occurs in the stomach is twofold. It's chemical, but it's also mechanical. There is a term for the mechanical processing that happens in the stomach, and the term is this: segmentation. Because it segments off. Basically, a section of the digestive tract. Here we're talking specifically of the stomach. It doesn't really happen anywhere else in humans. Closes at both ends. To contract in the middle. And not just once, but many, many times. Multiple times. Sometimes over the series of hours. Right now, that's happening in your stomach. Segmentation is occurring in you right now if you ate lunch. Here I want to tell you what both ends are, though, too. If we're in the stomach, both ends that it closes on, at the top, it's a little J-shaped curve there. Wow. Okay. It's going to close here and here. At the top is the lower esophageal sphincter. And down here is the pyloric sphincter. As I alluded to earlier, you can have problems with either of these two sphincters. The one that's most common, the one they sell a lot of medication for, Nexium, Prilosec, Prevacid, Tums. There's lots and lots, and I'm sure they've come up with new ones as patents have expired on older medications. They come up with new ones. This was Prilosec. When Prilosec's patent went up, they came up with Nexium, and at the same time marketed Prilosec OTC that people could get without a prescription. I think Nexium's over the counter too now, but it's basically all these different types of things are meant to battle when issues here occur where acid can churn back up into the esophagus, which does not have a protective lining. Your esophagus does not have a mucus gel layer, so it's very easy for acids to erode this. If this sphincter is loose or distended or doesn't seal properly, it's easy for acid to move up that way. Now, this sphincter really only becomes a major issue with babies. A lot of times babies are born with their pyloric sphincter closed a little too tightly, that even when it opens, it doesn't allow materials to pass through as it should. It's a condition known as pyloric stenosis. It's fixed surgically, and it is diagnosed by projectile vomiting. Not just like spitting up, because all babies spit up. They're like, bleh, puke comes out. That's just normal. But we're talking about they fire out a stream of vomit, like that's intense. So that's what that is. So if you see that or hear that, that's what causes that. All right, last little thing here. We're going to do functions of the stomach, and then we'll call it a day. And we'll look at the histology tomorrow. Functions of the stomach include what? What does it do, gang? Yes, okay. Chemical digestion. breaking chemical bonds using acids, acid and enzymes. Okay. What else?
Absorb nutrients, be one?
Not much. Very few things can pass through there because of that mucus gel. There are a few things that can. Aspirin can go right through, but they say every time you have an aspirin, you have a small ulcer because it's really hard on the stomach lining. Alcohol travels right through it because of its polarity, but most things really don't.
Does it store food?
Yes, so bulk storage. So we don't have to constantly be grazing, though some of us do. We can store food for several hours at a time before having to refill again, so that we've got more or less a tank. Besides chemical digestion, what else do we have? Yeah, so mechanical breakdown. Of food in a process called segmentation. That's what that is, mechanical breakdown of food. The last one is a lot less intuitive, and this is the last point we're going to write down today. Production of intrinsic factor. It seems like a small thing, but it's very much worth mentioning. So much that it made the top 4 list in what the stomach does. Okay? Intrinsic factor is a special chemical that is produced by the stomach and just by the stomach to allow B12 to be absorbed. B12 is a big molecule, and it's weird looking, and it's got cobalt in it, of all things. Yeah. You get it in like white meat chicken, liver. You get it in clams, stuff like that. But you cannot get it in plant products. It's only in animal stuff. All right. Why do we need B12? Okay. B12 allows red blood cells to be made. Without B12, we can't make red blood cells effectively, and it results in a condition called pernicious anemia, which basically your number of red blood cells continues to diminish as a result of that. Now, people that have that have to get B12 injections, and they're fine, but just to eat it won't help you, because if you don't make intrinsic factor, you can't absorb B12 and therefore won't be able to make those red blood cells. So,
Vegetarians have problems with that?
if they take a B12 supplement, then you can purchase like B12 supplements that still wouldn't be a problem. That's only if there's like people that have had stomach cancers and stuff and had portions of their stomach removed and don't produce that would have that.